The talk I'm going to give today is about a book project I'm doing, and so I'll really value input. It's meant to be a non-technical book, although as you'll see, there's some technical bits in this talk, and it covers quite a lot of ground. So I'll try not to talk too quickly, but I'm from New York, and it's sometimes hard for me to hold myself back. Okay, so the overview of the book and the lectures is about population over the last 250 years. Or kind of for people who think of it this way, population since the departure from the Malthusian regime, which I'll talk about more explicitly. And it's both what happened in the world and also how people thought about it. And in fact, a lot of what I'm doing in this book and in this lecture is kind of intellectual history, something that I'm not really trained or qualified for, but I'm giving it a shot anyway. And then I'm also going to talk, I think, as one must with demographic issues, about what's happening in the future, because we live in a very interesting time demographically. And I've organized the book, at least for now, and this talk as well, about this idea of catastrophe, and in particular, the catastrophes that people have worried about. So a little bit, there's a bait and switch here. I'm not sure that there is any population catastrophe, but I know that for the last 100 or more years, people have been worrying about a population catastrophe. And that's sort of what I take as my framework. And in fact, they've worried about 3 different catastrophes that you see listed here. So the one I started with, the one I learned about when I was young, was too much breeding, uncontrolled reproduction, the population explosion, which was going to lead to famine, and the earth was going to be pillaged of its resources, and so on. People have also worried about not enough breeding. So that's what we get much more today, the idea of birth dearth and subreplacement fertility and the end of society as we know it. And then finally, in parallel to these two, there's been worries about the wrong kind of people breeding. And here I put wrong in quotation marks to make it super clear. This is not my view. I don't think we have a problem with the wrong kind of people breeding. But over the last 150 or more years, various people have decided that various of the wrong kind of people were breeding in excess of the right kind of people. Now, all of these are old ideas. And if I had more time, I would actually take you through some of the history of these things. I have quotations going back all the way to Plato and to the Roman emperor in the 1st century and to Chinese sages and so on. People have always voiced some worries about these different population catastrophes. But it's really in the last century or century and a half that these have surged to prominence. So here, in place of that intellectual history, are some nice pictures. So this, again, is where I came into the story, overpopulation. So up in the right, you see the poster for Soylent Green, which was a movie about a population disaster starring Charlton Heston. The population explosion made it onto the cover of Time magazine. Many of us have read Paul Ehrlich's book, The Population Bomb. That was part of a very, very broad literature. And up in the left, it's an article that appeared in Science, a very serious journal, predicting population doomsday in the year 2026. I don't have time to really discuss that more, but we can discuss it over lunch. It's an example of an equation that fits super well in the data that they had that forecasts explosive growth of population that never happened. This is kind of more what's going on now with worries about low fertility. So Elon Musk and the Pope are both there, 2 very different individuals, but they're both very unhappy about low fertility. South Korea has a demographic crisis. The top thing that you can't see is about China having a demographic crisis. And the headline, can any amount of money turn the tide on global fertility? So that's kind of the fashionable worry today. And then early in the 20th century, a very, very serious and fashionable intellectual idea was eugenics. And one of the things that I've learned in the course of research for this book is just how mainstream eugenics was as an intellectual movement. This was not a fringe ideology. This was, prominent scholars, prominent people in business and politics. They just threw eugenic ideas into everything they did. It didn't mark you as some sort of deviant. It didn't mark you as having some crazy idea. The quotation that you see on the right is from E.A. Ross, a very, very prominent sociologist who coined this term race suicide in 1901. There's no bloodshed, no violence, no assault of the race that waxes upon the race that wanes. the higher race quietly and unmurmuringly eliminates itself via low fertility, rather than endure individually the bitter competition it has failed to ward off from itself by collective action. And this was absolutely, standard stuff that was used all over the place. On the left, you see a poster from a eugenics conference. Eugenics is the self-direction of human evolution. And again, the eugenics movement had an intellectual side. It had a popular side. There were books, there were movies, there were sermons that people gave about kind of eugenic ideas, all sorts of things that kind of, from our eyes, look horrific, but were discussed quite freely. So how did we get here? How did we get to this place where we sort of view population as a problem, or, kind of as we were discussing yesterday, how do we get to the place where we think there should be such a thing as population policy? Why is that something governments should take a role in? Well, I think to think about that, you need to kind of go back and think about population dynamics, and in particular to think about these kind of two canonical models of population dynamics, the Malthusian model and demographic transition theory. So here we get, a little bit of technical stuff. So here's the Malthusian model. Malthus didn't use equations or graphs or anything like that, but you can really take everything he had to say and summarize it with these two pictures. So on the top is a diagram that shows the relationship between population size on the vertical axis and income per capita on the horizontal axis. And think of this as, a pre-industrial economy where there's some fixed resource, land or fish in the sea or something like that. And so in the presence of a fixed resource, you're going to have a negative relationship between population size and income per capita. That's, sort of what Malthus and Ricardo and all those people knew full well. On the bottom is a relationship between income per capita and the growth rate of population. So that's something that environmental biologists would recognize. Malthus, of course, talked about how for humans, there was not just a kind of mechanical effect of income on fertility or income on mortality, but there was also a choice dimension to it. But it comes to the same thing. When income is higher, population grows more rapidly. So that's it. Two equations, two lines on graphs. That's going to give you a steady state. So if you look at the intersection of 0 with the population growth curve, there's going to be some level of income, YSS, at which population is neither shrinking nor growing. And there's going to be some size of the population, LSS, that's consistent with that income level, YSS. Okay, so that gives you a steady state. And of course, it's a stable, steady state. If population is lower than LSS, then income is going to be higher than YSS, population is going to be growing, and that's going to bring you back to the steady state. And the Malthusian model characterized almost all of human history up until a couple of centuries ago. And here's just, sort of a small part of making that case. We know there was little long-run change in the standard of living. We know that there was slow population growth on average, slow in the sense of, 0.1% per year, or half, or 0.20% per year for most of human history. And that matched the slow path of technological progress. We know that population was homeostatic, so that when there was a shock like the Black Death that wiped out a large fraction of the population, fertility adjusted, ages of marriages adjusted, and population came back to its steady state level. When we look across pre-industrial societies, say comparing Europe to East Asia, we know that when there were differences in the arrangements by which society determined fertility, so things like age of marriage or the prevalence of non-marriage, those were reflected in the standard of living, just as the model says they should be. And finally, and this is something that I think economists know, but I'm going to kind of put a new spin on it in a few slides. Historically, there was always a positive correlation between income or between social status and reproductive success. So there was a great replacement going on for all of human history, and that was replacement of the non-elites by the elites. The elites would sort of reproduce more than their numbers, and those extra children would filter down into the lower social classes. So that's good news. It means that we're all descended from princes and queens and kings and stuff like that. You can feel good about that. Okay, but that ended. So why did the Malthusian era end? Well, that's a very complicated story. Oded Galor and I have done some work on that. Many other people have as well. And I'm not going to tell the whole story there, but sort of the part of the essence for why that era ended was something that Malthus didn't think about. So Malthus convinced himself that higher income would always make people reproduce more, would always lead to higher fertility. And that's probably correct. But what Malthus didn't think about was all the other things that in practice have come packaged with higher income over the process of economic development and industrialization. And here's just, kind of part of that change in economic structure. So the value of child quality, education, relative to just child quantity, cultural change, including secularization and the elevation of women's roles in society, improved contraceptive technology, and finally, I've listed here, the way that modern states replace family as a source of protection and security and insurance. And so in this book that I'm writing, again, in areas that I'm not really very qualified about, I'm trying to kind of flesh a lot of this out and really talk about secularization and change in women's status and so on. So all of these changes reduce the desired number of children, and they also make it easier for people to hit the target of the desired number of children. So again, if you read Malthus, Malthus thought the only way that you can avoid having children was to delay marriage and remain celibate, and that was really, really difficult to do. And so when your income got just a little bit higher than subsistence, you were going to say, well, that's it, I'm not going to hold back on the number of children anymore. We live in a very, very different world than that. Okay, so that's the Malthusian model. What about demographic transition theory? Well, demographic transition theory stresses one of the drivers of reduced fertility, and that's reduced mortality. So when mortality falls, especially child mortality, people are going to desire fewer births. That's not something that happens automatically, but over time, social arrangements can change, people's mentality can change. And so lower fertility is going to follow from lower mortality. And in the lag between those two things, population is going to grow due to this excess of fertility over mortality. So this is kind of the standard picture of the demographic transition that I ripped off from someone, I'm not even sure who. We start off on the upper left with crude birth rates and crude death rates being very high by modern standards and roughly equal to each other. So population size is roughly constant. Then the death rate falls, and with the lag, the birth rate starts to fall. And so while there's a gap between those two, population increases. And then over on the right, according to this picture, which is something we'll discuss more later on, the birth rate and the death rate kind of come back into equilibrium with each other and population levels off. So don't hold me responsible for the lower right part of this picture because I don't actually believe it, but that's what the picture is. So I've been thinking about this for a long time, and in particular, and by a long time, I mean like 25 years. What's the relationship between the end of the Malthusian era and the demographic transition? And in particular, are these kind of the same thing? Is that one event or, two sides of a single coin, kind of different ways of looking at the same event? And after 25 years of thinking, I finally come to the conclusion that that's not right. That the demographic transition, by which I mean in particular the kind of mortality-induced fall in fertility, and the end of the Malthusian regime are two different things, two of the most epical things that have ever happened to the human race that happen to happen at about the same time. And my case that they're different things is really to think about, could one have happened without the other? So here's a little 2x2 matrix. So on top we have the mortality environment. So on the left is sort of high mortality, especially infants and children, and on the right is low mortality. And then on the vertical dimension, the question is, are we in this homeostatic Malthusian model? So the upper row is going to be, we have homeostatic population, Malthus is operative, and on the bottom row is non-homeostatic population. So the upper left and the lower right are kind of the two cells that define where humanity started and where humanity has mostly gone. So most of the world prior to 1750 had high mortality and homeostatic population. Increasingly, the world is moving to what we call a modern demographic regime with low infant and child mortality, which is a fantastic thing, and with non-homeostatic population. So this kind of, this Malthusian mechanism that nails the population, that anchors it, has just stopped being true. So that's kind of the course that the world has actually followed. But I want to make the case that the other two boxes are places where you could imagine the world having gone. So if we look at the upper right, So think about what would have happened if mortality had fallen within this homeostatic regime. So I made a picture for that. So to be concrete about this, imagine, Vienna or anywhere else pre-industrial in the year 1700 with the social institutions that were in place, with the economy that was in place. And now some aliens come from outer space and they say, here are antibiotics. And when women get sick after childbirth or when children get sick, you give them these antibiotics and they very, very frequently get better. But no other changes happen. So no change in culture, no change in industrial structure, no change in the quantity of land or anything like that. So Malthus didn't write about that. He didn't think about that case, but I think he could have. And in words, he would have done what I did in the picture here, which is just say that change, the introduction of antibiotics, is going to change the relationship between income per capita and population growth. And in particular, at any level of income per capita, population growth would be higher because people are not dying as frequently, even if they're malnourished. Well, what would that do in equilibrium? Well, we know in equilibrium, that's just going to lead to a lower steady state level of income and a higher steady state population. And indeed, I think that is exactly what the population pessimists, the Paul Ehrlichs and Garrett Hardins and all those people of the world feared. And it was not a crazy fear. I think that we came pretty close to that happening, as I'll try to argue later on. So you could just have a denser and poorer world that still operated according to Malthusian dynamics, in which you had lower infant and child mortality. The lower left box is a little more speculative, but at least my speculation is that I can certainly imagine a world in which there was high infant and child mortality, but in which we had industrialization and contraception and feminism and secularism and modern states and all the things that we have. And I don't think it would look that different from the world that we see now. So again, if you want to do the thought experiment in your head, imagine some terrible disease is introduced that raises infant and child mortality to 50% in our modern societies. That would be a horrific thing. But I don't think our response to that would be to raise fertility so much that we bred ourselves back into poverty. That is, I think I can imagine sort of a modern industrial, secular, and so on society, even if it had high infant and child mortality. Okay, so that's my case that the end of the Malthusian regime and the demographic transition are actually two different things. Let me talk a little about sort of the historical narrative, which I pursue quite a lot in the book. One of the things I spent a lot of time learning about was this reaction to falling fertility, a lot of which was news to me. So this all goes back much further than I had realized. So by the end of the 19th century, and particularly in France, where, as we all know, the fertility transition was more advanced than anywhere else, this decline in fertility was well recognized, frequently discussed. People said all the kind of panicked things about low fertility then that they do now. In France, that was overlaid, of course, with the horrible point that they had low fertility and the Germans didn't. And they thought that might turn out very poorly in the next war. And there were all these kind of clashing perspectives on that. There were people who called themselves neo-Malthusian. So as I mentioned, Malthus didn't believe in contraception. Neo-Malthusians were basically people who took the intellectual structure of Malthus and added in contraception and thought that this was a great thing and sort of we should be encouraging people, particularly poor people, to hold back fertility as the most efficacious way of fighting poverty. And there was kind of a conservative version on the UK and a very socialist version of that in the continent. There were pronatalists, so there were people who thought this was all a terrible idea. Émile Zola wrote his final novel, Fécondité, all about the foolishness of people holding back their fertility and kind of the beauty and vigorousness of large families. The American president Theodore Roosevelt wrote about this, talked about this quite a lot. There were feminists and birth controllers like Margaret Sanger in the US and Marie Stopes in the UK, who embraced contraception both as a means of bringing people out of poverty and as a means of liberating women. And then there were the eugenicists who, as I said, I've been reading quite a lot of in the last several years. So I'm not a proper intellectual historian, and so this is all kind of speculation on my part, but I think I've come to understand the origins of eugenics differently than how I read about it. So I read about the origins of eugenics as kind of an intellectual movement. Francis Galton studied hereditary genius and decided that we should kind of improve the human race. People were discovering about the genetic basis of development, of human development, and this all kind of came together in this horrible idea of eugenics. Here's my kind of alternative interpretation about the origin of eugenics. So kind of the first observation is that the early adopters of fertility control, and everyone who wrote about this noted this point, were elite and educated women. So, it was kind of widely commented on that the elite women were having fewer children. So that was one thing that was going on. And then secondly, public health improvements over the course of the 19th century lowered the mortality gradient relative to income. So it used to be that poor people simply died at a much higher rate than rich people, and improvements in public health and sanitation and so on made that go away. And this is, of course, speculation on my part, but I think that together these kind of reversed for the first time in human history this pattern where elites out-reproduced the lower classes, and instead we sort of ended up in a situation where the lower classes outbred the elites. And I think that those things, rather than, as I say, kind of Galton and company, were really the drivers of eugenics. And just to kind of make one point about this, the idea of breeding better humans is not Galton's idea. That idea goes back to Plato. And people have been sort of, people understood breeding of animals and breeding of plants for thousands of years before Galton and the discovery of the genome and stuff like that. So the idea of breeding humans, if you wanted to, was not some kind of late 19th century invention. Here's Charles Darwin in The Descent of Man. This is on the subject of mortality. With savages, the weak in body or mind are soon eliminated, and those that survive commonly exhibit a vigorous state of health. We civilized men, on the other hand, do our utmost to check the process of elimination. Thus, the weak members of civilized societies propagate their kind. No one who has attended to the breeding of domestic animals will doubt that this must be highly injurious to the race of man. And here's on the other side, on the contraception side, this is Marie Stopes testifying at a trial. The object of the Society for Constructive Birth Control and Racial Progress is, if possible, to counteract the steady evil which has been growing for a good many years of the reduction of the birth rate just on the part of the thrifty, wise, well-connected, and generally sound members of our community, and the reckless breeding from the C3 end, where C3 is the lowest military designation. So, these people were kind of coming together, sort of making this point about what was changing. Eugenicists, their initial reaction to this was to oppose fertility limitation because they saw that fertility limitation was being taken up by these elites who they thought were the wrong people to eliminate fertility. Sometime around World War I, they kind of gave up on that. They gave up on persuading elite women to reduce their fertility. And instead, they kind of focused on getting contraception into the hands of the lower orders of society. So they kind of allied with the birth controllers, first with respect to their own countries. And of course, this prefigured the post-World War II spread of this idea that sort of the rich countries in the world should be helping the poor countries or the people in poor countries adopt contraception. Okay. One of the fascinating things that I learned about in all of this research was that it was the eugenicists who figured out that there was going to be a thing called the population explosion. And again, this is a much longer story. A lot of it goes through the Office of Population Research at Princeton University, where many of the great demographers that we all learned from trained. So here's sort of a super brief narrative of it. So of course, American eugenicists opposed immigration from people other than Northern Europeans because they were quite confident that those were sort of bad people. Here you see The Rising Tide of Color by Lothrop Stoddard. It's just sort of an example of this. That drove them to think about population growth elsewhere in the world. And that got them to thinking about the determinants of population elsewhere in the world. And they sort of understood that if there were improvements in health elsewhere in the world, that was going to drive population, and as they feared, immigration. So here's, again, the sociologist E.A. Ross, sorry for the long quotation. Now, in 40 years, the advanced societies have experienced an astounding fall in the death rate. They've achieved a new longevity, which is destined to be shared soon in varying degrees with all the important sections of mankind. Wherever it arrives, population leaps like a startled hare. Certain enlightened peoples, to be sure, have their reproduction under control, but so far probably less than a sixth of the human race has applied any brake to its fertility. Unless this practice spreads much faster than it seems likely to do, overpopulation and therewith misery and degradation will sensibly increase throughout large parts of the world before the close of our century. That all happened, right? So he kind of, in 1927, he basically understood what was going to happen in terms of health in the world, and he understood what was going to happen in terms of population in the world. And then he ends with this chilling quote, how little the pioneer microbe quellers divined such an outcome of their exploits. And that's chilling because, of course, it prefigures this idea that was, bandied about quite seriously during the population explosion, that maybe it was a bad idea that rich countries were helping poor countries save the lives of infants and children in those countries. Okay, this is what happened, the international epidemiological transition. So this is kind of one of the great humanitarian episodes in history, the rapid transfer of health technology from rich countries to poor countries, everything from, sewers to DDT to training birth attendants. It was an enormous humanitarian accomplishment. And sort of, if you want to understand the world today, I think, if you're a development economist or a demographer, kind of the most important thing to understand is that in the period after World War II, health technologies were translated. The ways of saving lives turned out to translate very easily from rich countries to poor countries. But the things that made rich countries rich, the technology and the institutions and things like that, did not transfer in the same way. And again, that's a great humanitarian accomplishment, and we shouldn't think it was anything other than that, but that shaped the world that we live in. Okay, so here's just kind of one picture that gives you a nice graphic for that. So here we're looking at life expectancy at birth in Sweden, which was a kind of country where mortality transitioned early, and India, where it happened late. So on the horizontal axis is years since the start of that mortality transition. So in Sweden, that's 1805 when it starts, and in India, that's 1953. And so you can see kind of in Sweden, there's this 200-year kind of gradual process of rising life expectancy. And in India, the slope is more than twice as fast. So, mortality falls much, much faster. Life expectancy rises much faster. And one of the results of that is that in countries that start the process late, you get a much larger multiplication in population. So here's Chenet's concept of a population multiplier, the number by which the population is multiplied during the transition between the pre-transitional phase and the post-transitional phase. So think about that diagram that I showed you. And here are some numbers for the population increase 1820 to 2010. These somewhat understate the full concept of the population multiplier at the top of the list, because France and the UK started their mortality transitions a little bit before 1820. So the proper multiplier would be a little bigger. And then at the bottom, because countries like Ethiopia and Egypt are far from done with their increase in population. But this is just sort of the general pattern that countries that we think of as developing or that start the transition later have these enormously larger population multipliers. And again, that sort of has shaped the world that we live in now and that will go on into the future. Here's a little data I gathered for a different project. I defined this concept of life expectancy improvement time, which is just the number of years it took a country to get from life expectancy of 35 to life expectancy of 50. That's what's plotted on the vertical axis. And on the horizontal axis is the year in which the country reached life expectancy of 35. The data are censored at 1800 because that's where it began. In fact, really some of those points there should move to the left and even further up because those countries achieved life expectancy of 35 prior to 1800. But you see that there's this super strong negative relationship. So countries that started the process later went through it far, far more quickly. And here's my one estimated equation for the day. So I looked at the relationship between that thing I just described, life expectancy improvement time, that's what's on the right of this equation, and the change in log population over the period 1820 to 2010, where here the sample is confined to countries where the native population was not displaced. So we're taking out most New World countries, and we're looking at kind of countries of old settlement where data was available. You can see there's a very, very strong negative effect of life expectancy improvement time on the size of population. So the faster was your life expectancy improvement, the larger is the increase in log population. And there you sort of see the interpretation. A 1 century faster transition raises population by a factor of 3.1, which is a lot of big increase in population. Okay, so kind of this brings us back to the population explosion that I talked about before. What I grew up on were these doomsday forecasts, the population bomb by Paul Ehrlich, the battle to feed humanity is over. We're going to experience massive famine in the next few decades. Nothing can prevent that. Another book I read with the great title, Famine 1975, exclamation point, America's Decision, Who Will Survive? So kind of all of this discussion was about triage and about lifeboats and about how we can't save everybody and we have to let a lot of people in the developing world die. And that would be the humane thing to do. And of course, that was all wrong. The doomsday forecasts were wrong. There was no triage. There was no massive deaths. There were no famines. Nutrition today is far better everywhere in the world than it was at the time that people were making these terrible forecasts. And there were two reasons for that. One is the Green Revolution, which gets a whole chapter in my book because it's kind of, I know I keep saying that in this talk, but it's one of the most epical things that has happened in human history. And the timing of the Green Revolution is just a fascinating topic. Why the Green Revolution arrived just when it needed to in order to avert famine. The longer term reason is that fertility fell faster, and in particularly it fell in undeveloped countries at lower levels of income than anyone or almost anyone thought would have been possible. So it was kind of this surprise that fertility could fall as quickly as it did. And sort of one way of summarizing that is by talking about the 1974 UN population division projections. This was kind of the high point of the population panic. They thought there would be 12.2 billion people in the world by 2075, and the population would still be rising rapidly. And we think, of course, that's by now a crazy forecast. There were exceptions to the rule of falling fertility, like much of sub-Saharan Africa and Pakistan. There are a huge number of kind of interesting questions that are thrown up by all this, which I obviously can't talk about today, but if you want one picture, here's China. Total fertility rate in China is up around 6 until 1970. And then we get kind of the two policies, first the later, longer, fewer, and then the even more rigorous one-child policy. The total fertility rate goes down in that picture to 2. We know, of course, now the total fertility rate in China is well below 2. And the one-child policy was replaced by the two-child policy. Two-child policy has now been replaced by the three-child policy, and China still has super low fertility. So, of course, there's a fascinating counterfactual to be done of what would Chinese fertility and what would Chinese economic development have looked like in the absence of those policies. And in particular, can you make the case that this draconian fertility reduction policy was actually necessary for Chinese economic growth? I don't have the tools to do that now, but I think that's what people should be working on. Okay. So the last thing I want to talk about, or the second to last, I guess, is what happens at the end of the demographic transition. So remember the picture I showed you before, where kind of very nicely fertility and mortality came together at the end of the story, and population leveled off, and we were kind of back in this equilibrium, and we kind of went into the future with this beautiful constant population. Well, my own view, and I feel bad coming to Vienna and saying this because I think this is kind of the view of everyone in Vienna, is that that's just hooey, and that there's no reason to think that population growth should settle anywhere near 0 once the demographic transition is over. That is, Malthus gave us an anchor for 0 population growth for most of human history. That anchor has now been pulled up, and there is no homeostatic process that should push us towards 0 population growth. I'm writing a paper on this, tentatively titled "Replacement Fertility is Neither Natural nor Optimal nor Likely," which I guess is a good title. And so, in that world where there's no anchor, the total fertility rate is going to depend on preferences and institutions and culture and so on. And that may settle at above 2.1, or that may settle at below 2.1. And we shouldn't be surprised at either of those. So we shouldn't be surprised at persistent sub-replacement fertility. And we also shouldn't be surprised at persistent above replacement fertility. And here I put this idea of stalled demographic transitions in quotation marks, because I think that's a kind of term you see a lot, but there's a lot of kind of spin behind that term. So if you say such and such country has a stalled demographic transition, it kind of implies that you think that all demographic transitions end at replacement fertility, and that country is kind of like a bad child that hasn't gotten there yet. I just think that's not the right way to think. I think that we don't know that demographic transitions should end with replacement fertility, and so we should kind of not use that language. All right, so this is the last topic, sub-replacement fertility. So as you see on the slide there, more and more of the world lives in countries where fertility is below replacement, and more of countries in the world now have explicit pronatalist policies to try to undo sub-replacement fertility. Oh no, this is a shame that the thing is blocking the title of this slide. So this slide is showing you a graph from a picture from a paper called something like Improvements in Human Development, Reverse Fertility Decline. So this is a 2009 paper by Hans-Peter Kohler and others that argued that, okay, we have sub-replacement fertility in rich countries. There seems to be this phenomenon that as countries get richer, fertility falls. But if you look in the 2005 data, there's this kind of J-shaped curve or reversal or whatever you want to call it, where when the Human Development Index gets high enough, fertility comes back up. So that seemed like a kind of encouraging thing, sort of to point us towards this idea that that maybe replacement fertility was not such a crazy idea, and if every country became more like Sweden, or Austria is probably in there too, fertility would come back towards replacement. Here's the same, it took me a while to get the scale of this right, because it's this very odd metric of the negative log of 1 minus the HDI on the horizontal axis. But here's my replication of their picture for 2019 data from the United Nations. And it seems like that kind of reversal is gone. And this is pre-COVID, of course. It sort of seems like in the data that we have, the high human development stabilizes fertility, but it seems to stabilize it at some level below 2 on average. And that big outlier with fertility of 3 is Israel. Okay, so that brings me to the last thing I want to talk about, which is population aging. So everyone's very upset about the economic effects of low fertility and population aging that follows from it. How can we think about this? How can I think about it as an economist? So we know that higher old age dependency lowers consumption for all. That's kind of what Elon Musk and so on are on about. But of course, aging populations also have fewer children. Children are also extremely costly. They cost a lot of time. They cost a lot of money. And so if we're going to think about the economic effects of low fertility, we really need a framework that puts those two things together. And so this sort of summarizes previous work that I've done on this purely graphically. This is kind of a way of thinking about dependency and its economic effects. So on the horizontal axis, we have the fraction of the population aged 0 to 19. And on the vertical axis, we have the fraction of the population aged 65 plus. So you can represent the age structure of the population by a point in that space. And so you see I've put Korea in that space. And the other thing you can do in this space is think about the level of dependency. So if we just sort of as a super quick shortcut think of old people and children as costing the same thing, and all working age people as being the same, we can obviously fix all of those and make them a little fancier. Then you can represent the level of dependency in a society by one of these isodependency lines. So combinations of child dependency and old age dependency that add up to a fixed level of dependency. And so here, I've labeled them 50% working age, 70% working age, and so on. So the closer is the demographic structure to the lower left, the more the working age fraction of the population, the less dependency. and holding other things constant, the richer the country is. So in this space, you can then graph the demographic structure of a country over time. So this is actual data from Korea going back to 1950, and then UN forecasts going all the way to 2050. And we can see that over the course of fertility decline, Korea traces out this kind of bowed-in shape in which it goes from very high dependency, 50% of the population or more being dependent, down to quite low dependency, so near 70% of the population being working age, and then, unfortunately, over the next 30 years, rising dependency. And so it's a very nice way of looking at this, and you can easily generate these pictures for any country you want. Okay? So we can go further and sort of talk about the actual effect on income per capita. So we can just write GDP per capita as the product of GDP per worker and the number of workers per capita. So the growth rate of GDP per capita is just the sum of those two growth rates. And so it's pretty easy to calculate the growth rate of workers per capita. So there you see for Korea from 1975 to 2000, the working age share rose from 0.46 to 0.64. And so that's like a 1.3% growth of workers per capita. You can think of that as kind of a tailwind to the process of economic growth. Obviously, a lot of other things were going on in Korea, but the fact that demographic structure was changing so advantageously added 1.3%, which is a fair bit, to the growth of GDP per capita. But you can see from 2020 to 2050, you then get the opposite. You get this headwind, which is holding back the growth of GDP per capita by about 1.1% per year. Okay. Now, some people have gone further and sort of tried to make the link from these changes in economic status to, back into fertility, often, with very sexy titles, like this is going to lead to a demographic meltdown. So just to kind of flesh that out. So we know that aging is driven by low fertility. We know in the case of countries like Korea, or indeed, Northwest Europe and so on, low fertility was not driven by slow economic growth. So South Korea experienced super low fertility at a time when it was growing very quickly. But you still might imagine that if countries start experiencing slow economic growth because of population aging, that's going to feed back into even lower fertility. I don't think that's a crazy idea. So think about, Italy or someplace like that, where they have hugely rising pension costs and taxes that have to support that. That's going to make it all the harder for people to raise children in Italy, and they're going to respond by having lower fertility. You can maybe convince yourself that there's going to be some kind of negative feedback loop, and we're going to end up in a meltdown where kind of we only have old people and we're all paying super high taxes to support them. No one has children and society kind of vaporizes. Now, my own analysis has kind of not shown that to be the case, but it's nonetheless an idea that's out there. To give a different perspective on this, on sort of, so if you sort of looked at all that, you would kind of be with, I guess, Elon Musk and the Pope, and you would say, wow, low fertility is really bad. Look at the terrible damage it's doing economically. But I think with our demographer hats on, we can do a little better than that. So, we know that changes in fertility only feed gradually through the age structure to changes to kind of increased old age dependency. And we know that when fertility falls rapidly, as it did in Korea, there's this period in which both old age dependency and youth dependency are low. This is the demographic dividend that people like David Bloom have written so much about. But we know that that can't last. The demographic dividend, by its nature, has to be temporary. And so, kind of a natural thing to think about is not this sort of transitional thing, but rather the sort of stable population as demographers think about them. So that's going to be a population in which the growth rate of population has been constant, fertility and mortality have been constant, and so the age shares the population. So going back to the Korean case, here I just constructed a set of stable populations for Korea using the current life table for Korea. And you can see that has a little bit of the bowed-in shape of the actual path of dependency in Korea, but it's far, far less bowed in. And here, I guess, is the two of them together, along with these isodependency lines. And along the stable populations, I just labeled steady state population growth. So sort of looking at that picture, you can see that, yes, it's true that the working age share of the population for a stable population when population growth is 0 is a little lower than when population growth is -2%. but it's a quite small difference compared to the differences that are experienced along the actual transition path with the demographic dividend ending. And so the point here is that, I'm not saying that there's not sort of some optimal population growth rate that might be higher than the current one in Korea, but in steady states, differences in population growth make far less difference to dependency than this change in dependency along the demographic transition. And this got me thinking about the right metaphor. So I was talking to some journalist about this, and the journalist said, and we were talking about Korea, and they said, well, dependency is rising. This is like a hangover. This is the hangover from the party that we had from low fertility and low dependency. And I think that's wrong. So what's a hangover? A hangover is, you go out Saturday night, you feel great. On Sunday morning, you feel bad. And not only that, so you feel worse on Sunday morning than on Saturday night, but you feel worse on Sunday morning than you would have if you had not gone out on Saturday night. That's what a hangover is. But if you go back to this picture, that's not really the case, right? What's going to happen is when all of this demographic dividend is over, Korea is going to be in roughly the same place it would have been in if it had not gone through this whole demographic arc. So the right metaphor is more like the end of a pleasant vacation. You feel good while you're on vacation. When the vacation is over, you feel worse than you did on vacation, but you don't feel worse than you would have if you had not gone on vacation. So I think that's a way in which sort of people fool themselves into thinking that it would be great if fertility went back up. Okay. There's some nuance there that I'm just going to skip. I'm going to skip all that as well. Okay. I've spent some time looking at the efficacy of policies to raise fertility. So I kind of just showed you that I'm not sure that raising fertility is really a good thing economically, but people spend a lot of time thinking about it anyway. And I tell my graduate students that this is just an issue you got to work on, because for the next, I don't know, the rest of their careers, people are going to be spending a lot of time trying to raise fertility. And so there'll always be a lot of demand for it. There's a lot of work by this sociologist, Lyman Stone, on the issue. He finds that the best policy is the provision of high quality childcare, but countries do all sorts of things, including cash bonuses for babies and all sorts of stuff like that. From his work, he kind of pulls out a cost of raising fertility, and I tried to apply this in the US case. So I looked at the cost of raising the TFR in the United States from 1.7, so that's its pre-COVID level, which is very low for the United States historically, but of course by European standards, that looks pretty high. To raise it from there to replacement, 2.1, so that's not very far, but that would cost $5,300 per child per under 18 per year, or about half the value of the US defense budget. It's a lot of money. I don't think that's crazy. I mean, I think if I was president, I'd be very happy to do that, because of course, all these policies that raise fertility help families and they take care of children. I think those are good things, but it doesn't come cheap. It's not like giving you $10,000 to have a kid is going to raise fertility. People seem to be smarter than that. Okay. I'll just say this. Well, no, I guess I'll say this. Okay, so as I said, the steady state analysis says that raising fertility is maybe not that important. Nonetheless, policymakers seem to care about it, maybe for other reasons, maybe for military reasons, maybe because they care about the utility of future unborn people and future potential people. I think those are all really interesting questions, but I'm not going to talk about them here. But I do have a caveat, which is sort of when you think, well, we're in this terrible problem with dependency. So, we're Italy or we're Austria, and we're facing population aging. We're going to have a lot of old people because we've had low fertility. Maybe we should raise fertility to fix that problem. Well, there's a huge logical issue there, which is that when you raise fertility, what you get are a lot of young dependent people, which take quite a while to turn into middle-aged productive people. And so if we kind of go back to this picture, here's the dependency dynamics in Korea. And here I'm thinking about what happens if you raise fertility. And of course, the answer is you get many decades in which total dependency is even higher than it would have been on the path that you're on. Now, eventually those red dots kind of spiral back in a really kind of cool way. But if you're a policymaker, that's like well after you're dead. So if you think that raising fertility is the solution to dependency problems, you should worry about these kids taking so long to grow up. Okay, so kind of briefly on the subject of subreplacement fertility, subreplacement fertility is going to impose this headwind, but it's really just the ending of the demographic dividend. this kind of period we had of particularly low dependency over as a result of low infertility. And I think, sort of the bottom point there is kind of where I come down. If low fertility is a problem, it's not a problem for conventional economic reasons, at least that I can understand. Okay, and here's my last slide. The general conclusion and sort of the theme of the book. The end of the Malthusian regime means that we've eliminated this homeostatic anchor for population. And we have to get used to this idea that replacement fertility, very interesting concept, but there's nothing natural about it. There's nothing optimal about it. There's no reason to think that fertility should be coming back to the replacement level, or that there's something wrong with the society where it doesn't. And that we're all just very, very bad at thinking about this. And, Alexia and I, a couple of days ago, sort of had a conversation about this, where it sort of became a running joke, where, she would say, well, the problem of low fertility. And I would say, wait, why is it a problem? Of course, it's an intellectual problem. It's a fascinating intellectual question. But I think we're just very bad at sort of getting our minds around the idea that replacement fertility is not where society should be. So that's the end, and I would love to take any questions or hear any comments.